All right. Well, welcome to day 7 of Quick Pass. This is a exciting lesson because we're not introducing anything new as far as Python basic data types or collections. So this is just going a little deeper into complexity when it comes to how we can present data, store data, and modify data, and it just adds another tool to your toolkit. So this lecture today is going to be over mutating two-dimensional lists. I don't anticipate it going 2 hours. I really feel like we can introduce the concepts fairly quickly, and then we can go over quite a few examples to kind of see how we can manipulate data. And we'll start with a bit of a review. We'll go back into lists a bit, and then we're going to go over iterating them, using those for loops, introducing those for loops again, and then we'll start looking at the two-dimensional lists. So again, with lists, remember the syntax for designating a list is with the square brackets. So we have my list equals. We have a square bracket, and then we can, of course, have any type of data in there. So we can have a string. We can have an integer. Oops. We can have floats. We can have tuples. We can have a set. We can even have dictionaries. So we can have all those things. Just remember those individual items need to be separated by commas, but that's how we can then designate a list. And of course, if we take a look at the length, so that's another method we have, is the length. It's a pretty important one because you'll be checking the length of lists all the time when you're iterating over them, using the length to come up with a certain, the range. We can check the length of my list by running that. We can see there's 6 items in here. Now, individual items, there's a lot more than 6, but remember, in a list, you're only looking at the top level, so 1, 2, 3, and then this is a whole item. It's a tuple. This is an entire item. That's a set, and then this is an entire item, and that is a dictionary. So they're ordered indexed, so I can access them by using the index. So if I want to get that dictionary out of my list, I would need to use the index of it. It's a 6-item list, but we know that we start counting at 0 and we count up. So I need the index of 5. And if I were to run that, I'd get back the dictionary that's at that index of a list. So it's ordered. It maintains the same order. It has a position. You can use that to your advantage if you're storing data and you need to access some of the data you put in there. You can access it using the index. And again, creating a list, I created one with stuff already in it, but I can also create it with a constructor, just like that. And of course, I'm not going to access an index that doesn't exist. I'll get an error, but I can call that, and I have my empty list there. And just remember, if this list was 1,000 items long, or some random length, right? And I don't know the index of the last item. Of course, I can, if I get the last item in the list, I can always use a -1, and that will get me the last item in the list as well. And that also gets me that dictionary entry. So that indexing, the indexing is important. Just remember you have that positive and negative indexing. Any questions on that? It's a bit of a review on the lists. There actually is one more thing I wanted to share with you. There's a couple of methods that we didn't include. And this would be useful if I had a list of numbers. Let me just make a list of random numbers. We also have the max and min. And so this is a bit new, but you may have seen it. If I run the max method on this this list, it'll go and find the maximum value. Conversely, I have the min, which is the minimum, and it will give me that returns a 1. So it shows me that the lowest number in that list is a 1. It only works if you have all numbers. So if you have a mixed data in your list and try to run that, it's going to give me an error because it doesn't know how to compare a string and an integer. And it's going to say, I have no idea how to tell you if a is less than or greater than or equal to. Well, I can tell you if a is equal to 1, but it'll give you a false, but it cannot tell you if it's less than or more. You'd have to convert it somehow. You could find if you want to compare the ASCII value of the a compared to these numbers, you could do that. There's ways to do that in Python, but you can't run these max and min methods with lists if you have mixed data types in there. So just keep that in mind. And that was it. Those are the only two I kind of wanted to show you, just in case you want to add those to your toolbox. It's pretty easy to use. And there's others as well. There's like absolute value, and that will give you the always positive, whether it's negative or positive. It'll return the positive integer. So, any questions on that? Okay, well, let's move into the nested lists or lists within lists. We call it two-dimensional lists. And really what it is a list of lists, and it's like having rows and columns of data. So it's very common in development to see lists like this, and you would have to know how to access those the data depending on what you're doing. In these simple examples, we have a matrix up here already have in this cell, and it is a list of 3 items. So I have one item here, I have another item here, and then I have another item here. And inside of those items are other lists, which then have their own indexes. So if I wanted to, look at the first row, I could say my matrix at the index of 0. And if I were to run that, let me run this cell first, get it into memory. Now it'll run. And there we go. I have the first row. Of course, I can change that to a 1. And I can see the second row, and so on and so forth. So it's just a way to see each row as its own entity. So that's each index. If I wanted to break it down and see just an individual number, I would have to drill further into it. So if I wanted to look at the number 10, I could either do index of 4, or conversely, I can use what number? To look at the 10 right here. -1, that's right. So use 4, and I can see the 10, or I can change this to a -1, and I also get 10. So I get to the same spot. That is how you can access any portion of a nested list. I could go even further, and I could even have more data inside of even a further nested list. In this case, I'm going to do -1, -1, 0. This goes a little deeper. Oop. Let me try that again. -1, -1, and 0. Let me see if that's giving me an error. No, that's right. Oh, let me run this real quick. That's why I changed it and didn't run it. There we go. Now I've accessed this one because I'm going even further, and you can drill further and further down. So we're going to stick with two-dimensional lists though, so we won't go any deeper than that. Just to illustrate though, you can just take this concept further and further as needed if your data type has that. You won't have any of that over what I just did here.
Like what the -1, -1, 0 is accessing.
Oh,
so it was the last, sorry.
So yeah, so I had already changed it back, but I'll just go ahead and put it in here. So there we go. And so here in my matrix, I have a list that contains lists, but in this last entry, I actually have another nested list. So I'm just going even a level deeper than 2 dimensions, just to show that this process is repeatable, that I can go even further. So in this case, to access this right here, this object, I would have to, or that list, I would have to add another entry in here to go to it. So if I want to access the 3 that is right here, it would be, yeah, it's like a 3-dimensional list at this point. But, I was just, yeah, Listeception. So in this case here, if I want to access this 3, the -1 is just accessing the last item of each list. So I'm going to this item first with the first -1, and then I'm going, or this whole thing right here, and then I'm going to the last item in the nested list, and then I'm going to the number 2 index there. So if I were to run this, I get the 3 back because I'm accessing this 3. So again, that goes a little further than what the lesson has, but I just wanted to illustrate that it's really easy to repeat that and just go deeper and deeper if you need to. We're going to stick at 2 dimensions though. So here, let me run that and then run this. Now I have the -1, -1. On my matrix, -1, which is the last item in that outer list, and then I do another -1 to get the last item in the nested list. So I'm going for this last item with this -1. Any questions on that? If I want to iterate over the lists inside of the matrix, I would need to do to use for loops. And so with that, we would want to write a for loop. And can everybody remember how to write? If I want to write I want to write a for loop to loop over each of these items right here as a whole. So not going any further. But if I wanted to loop over each item in matrix, how would I write that?
For item in my matrix.
Okay, so for item in my matrix. Okay. And then doing that, I can do whatever I want, right? I can print out that. So I can say print item, and I can run that, and it will print out each one. So it runs 3 times, makes a for item in my matrix, print item. Okay. All right. So that's a little bit of review on for loops. On a very, you know, in the one-dimensional level, it's pretty easy. You can write a for loop like that. I could also write a for loop another way, and I could say for I in range len my matrix print my matrix I. And if I run that, I get the same exact result. In this case, what I'm doing, I'm using the range method, and I am saying I want to go from 0 to up to, but not including the length of the matrix. So the length is 3, right? So really, this is saying for range in len 0, 3. That's the same thing. But in this case, I'm using the length because I don't know, like, I may not know how long my list is. And so I want to use just the length of it. So I would do that. And then when you do that, you have I as your, that's going to count up every time the loop iterates. So it's going to start at 0. So I'm going to print my matrix at the index of 0. And then when it iterates again, it's going to be a 1. I want to print my matrix at the index of 1. And then again, I'm going to run it the last time, and it's going to be 2 because it's up to and not including the last. So the length is 3. It goes up to, but does not include 3. So I'm going to get 0, 1, and 2 as my values for I. So each time this iterates, I'm going to get those, and I'm just printing the same way I'm doing it here. I'm just running in a print statement that changes every time this loop iterates. Does that make sense? Great. Awesome. But we can take this a step further. So let's say I don't want to print out the lists of items. I want to print out every single item. So one at a time. So on each line, I want to print out a new item. I would have to do something different. And what I would have to do is a nested loop. So I'm going to use a nested loop to then go into each element of each row. And that's how you iterate through a nested list. Now, I'm going to use the same syntax here because I'd rather introduce it this way first, and then I'll show you another, the other way, which is with simpler loops. But I can show you this way as well. So in this case, I can't use I again because I is already being designated as a value. The standard for doing a nested loop using this method, typically you're just going to use J. Because this really I stands for index. You could also sometimes you'll see it like IDX, right? But a lot of times it's shortened to for I in range, whatever. It's been defaulted to just use J, which is like the next letter in the alphabet. So that's typically what you would do for nested loop. But this really could be anything. You could say for row, but see, this is going to be an index using this. So it's right now it's for I and then J. And so and this one will be range len. And what this is doing is when this first loop runs, I is going to be 0, and you're going to look at each row, and then when you use this J, you're using another index that starts at 0, and we're going to see the length of each element in each row. So you're going to see how the length of just this element, which is my matrix, the index of I. So when this starts at 0, So I'm gonna be looking at my matrix 0 and then the length of all those in there. And then I can print my matrix I j. And when I print that, that's what I get. So I'll get 1. So when we see this run, we can see we start at 0, and it's going to stay 0 while this loop runs. And this loop's going to iterate over every single thing in that first element. So it's going to be I is going to be 0, j will be 0. So it's going to print my matrix 0, 0. Then this j is going to increment by 1. And it's going to then be 0, 1. So it's going to see, you're going to iterate to the 2. Yeah, I was planning on pulling a Python tutor so you can see it step by step. Yeah, it's fine. Yeah, I was just trying to explain a little bit first before I go in there, so it's visualized. So the third time this iterates, this j is going to be a 2. And so I'm going to go back down to the print statement. I will still be 0, and j will be 2. So I'll be accessing this element, and that will be 0, 2, and so on and so forth. It's going to go all the way to the end of 5, and then it's going to go back up to this outer loop. I is going to increment by 1, so then it'll be my matrix at I, which will now be 1, and do the same thing and hit each one of these. And so that's how these loops are going to iterate. But yeah, I was going to pull up Python tutor for you so you can see it as well, because we all love that step by step. Python tutor. All right. So here we have our loop, we have our matrix. And let's do something different. Let's go ahead and let's do capital letters here. All right, there we go. All right, so we have 41 steps in this this loop. So what it's doing right now, it's just getting, what the matrix is. And so now it sees that, matrix is a list, and inside of it, each element is also another list. And so it's going to break it down and kind of show you what it is. And you see how we have the first index is just integers, 1, 2, 3, 4, 5. I made the second element in that one all letters, and then the third one is back to numbers. And so it's running through this loop. And so if you see here now in our global frame, it shows I as 0. And then I'm designated a nested loop. So j is also 0. And so then I'm just printing my matrix at I, j. And so that will be my matrix, and then I is 0, and then j is 0. So I'm going to print the 1. And that's what the print output is. It's going to go back, increment j by 1. So now j will be 1. Print my matrix 0, 1. It's going to increment it again, 0, 2, 0, 3, 0, 4. And then it's going to go back up to the outer loop, increment I by 1, and then repeat the inner loop 5 times. So now I'm seeing my index and I'm seeing my ABC being printed out all the way down to E. And then it's going to go to the last element and then start hitting each element inside that nested list. And then the loop is done. Any questions on that and how to use a for loop and use a nested loop in there? Conversely, I can change my loop. And I'm gonna add another code block here. Let me go ahead and clear these outputs. There we go. And I can say for row in my matrix for element in row print element. And I get the same thing. Yeah, that one really helped me. When I was learning how to code, I was using that site like crazy, and it really does. Sometimes it can get a bit weird when some data types will have just too many arrows pointing places, and just it makes it a little more confusing. But just the step-by-step, being able to stop it and follow what it's doing helps you kind of debug. And IDEs have debuggers. I've never been good at using them. So if I can, I typically use that one because it goes step by step. But that is how you would do. These are two examples of nested loops going over nested loops going over nested lists, nested data types. And these nested data types, you could have tuples instead of lists, and you would do it the exact same way. So and this is kind of what I just went over. So that is how you loop. So let me clear these outputs real quick. If I want to change a value inside of my matrix here, so let me go ahead and I don't know why I collapsed it. I didn't want to collapse it. Go ahead and just play it again. So if I wanted to change, let's say I wanted to change the value of this 9 to the letter B. How could I do that? And you can just put an answer in the chat. Okay, I have append. Well, I don't want to add anything. I want to just change this list in place. So I don't want to add anything to the list. Okay, Athena has an answer. I may have to change this. Looks like it came across as a weird quotation mark for whatever reason. There we go. All right. And then go ahead and print it out again, or just show it. So Athena put in my matrix 1, 3, and I wanted to change this one here. It says equals B. Run that, and sure enough, we changed that 9 to a B. Okay, so replace. So my matrix replace. Wonder how we can do that. Let's try and do that instead. So let me run this one here again to bring it back. So now I've gotten rid of that B. And so instead of doing it that way, we'll say my matrix dot replace. Is that a correct list method? Let's pull up. Well, let's pull this up and see. This one says, how do you do it? So I don't know if there's that method, but we can use that indexing. I think the replace was for, it was for something else, right? It was for I'd have to go back into it. Yeah, I think it was for dictionary, if I'm not mistaken. Again, I don't have these memorized, and you can always just look them up, but you can just Google, a method, and if it doesn't apply, 'cause I didn't get anything on like the normal Python site. So and it didn't really give me a nice green color. See how it changed to green color? That usually means it's going to be something that's valid. You can also check in Jupyter Notebooks, you can always just do the dot, and then it'll come up with what you can do. So here, this kind of gives you all of your methods that you can use with a list, and then you can just hit you can just pick it by just selecting it. I think you can also just hit the down arrow and pick the one you want. So yeah, we can't really use replace. So really, that indexing was the best way. Access the indexing, the outer, the first level, and then you would access with another. So the 1 and then 3 would access that 9. So the 1 would be this row, and then the 3 would be the index 3. So 0, 1, 2, 3 to get the 9 and replace it with a B. And that's exactly what we did here. The same thing. So we can change the value by just using the indexing. And of course, you can add elements using append. So if we wanted to add something to the second row, you would have to access the row first, and then you would use your method. In this case, I want to add the letter C. Okay, I'm going to run this first, and then run this. And now I have a 6th item in the middle row, and I've added a C at the end.
Do you have to add an index when you're using append for lists, or is it just if it's a matrix?
Well, so a matrix is just a nested list, right? So if I want to specify wherever I want to add my value, so like here, right? So if I wanted to add this C to the last row here, I would have to put an index before it because I'm going to access whatever row I want, right? So the 0, 1, 2, if I wanted to add it to the last row, I would need to put a 2 here.
So if you didn't put anything, like if you didn't include an index, what would it break the code?
No, you would append a C, right? So let me go ahead and put it back here. But the C would be the last item in the outer. So now it's the indexes are 1, 2, 3, 4, 5, and the next one is 6, 7, 8, 9, 10. The third one is 11 through 15, and then the last item is your C. And so it would be like this.
Oh, okay.
Yeah. So that's what it would be if you didn't drill down to that index of the outer list.
Oh, okay. Thank you.
Yep. You see how that looked almost the same. But what I did was actually add it inside of this inner square bracket. Before, without doing that, it was in the outside of that inner square bracket as a fourth item in the main list. So again, just small details like that can really change how your code behaves. But when you're thinking about this, you got to make sure you're drilling down to the right level. So this one is very similar to this first example we have here with the seating chart. So this seating chart here, let me add a new code cell. We have our seating chart here. And if let's say this is just a chart with seats that you reserve, and then someone comes in and buys a seat, and they want to be in the front row, of course. Let's say this is going from the back of the stadium to the front. So this is the front row. These are the more expensive seats, right? Someone wanted the first seat where they have a good view of all the action, so they wanted to pick seat J. If you were to designate that as being sold, you could say, well, you could then just change it to like an X, like this one has here. So it's seating chart. And then what would I put to access that one seat? Seating chart.
You said J, right?
Yeah, this one right here.
So when you put 0, 1, 2, would it be 2, 0, 1?
So it'd be seating chart 2.
And then 1?
1. And then I would say sold. I can just do it that way, right? And then, of course, check my result by doing seating chart. Run that. There we go. Been sold. I can print. Gonna get a better view of it. Let's try it that way. No, prints out the same way. I'd have to iterate over it to get it to print vertically, but yep. You could also do -1 because that's the last item. Run that, I get the same result. This is a pretty good example too. This is showing a scoreboard. And here, if we want to maybe increment, if we want to increment someone's score by a certain amount, we could access the index. And so we would say scoreboard. Oops. Board. We can say 0. 1. Now Alice is 60 versus 50, and I just incremented it by 10. So this plus equals, if you remember from one of the first lessons, that's how you increment things up. So I'm accessing this integer, and that allows me to increment because it is an integer. So I'm bringing it up by 10 points. Daniel, you don't need a space after that because this is like a way to increment values. So it's a kind of like a shorthand, but it's very common to see. What this actually does is it takes whatever value you had before and just takes this value and adds it to it all in one line of code. It's the same thing as writing this. Equals. If I ran that, I would still get a 60 here. So this is the same exact thing as what I wrote before. Yes, yeah, it only works for numbers. So the plus equal, when you're incrementing things, it's only going to work with numbers, not strings or anything. Well, I mean, I think it, so that plus equals will work as strings, but it concatenates. So it adds stuff to things. It doesn't like do math for you. So this plus equals is just appending, or appending, it's concatenating two strings. It's concatenating this string, and then I'm concatenating this one with it. That's why I added a space in that to give me my name, basically. This example here is really like the first example. In this case, we have a grid of items and we replace one of them. When we use grid at 1, 1, we're saying grid at the first element of grid, and then we drill down to the actual element inside the sub element. So we're going to this X right here, and we're changing it to an O. That's how you would do it. It's the same exact thing as doing this operation. We add a few more code blocks. And we can look at adding entire rows and columns. So we can do that. So we have our sales data. And what this is doing is showing just rows like you would see in a spreadsheet. So it starts off with the first column being kind of the headers of each column. So you have name and then the month afterwards. So we have, looks like Alice made 100 sales in January, 120 in February, then 90 in March. Bob slowly increased his. We're adding new salesman or salesperson, Charlie. And we're going to put that stuff in there. So we're going to append this to the end of the sales data. So we want to append new salesperson that we designate as Charlie to the end of sales data. So if I were to run this and actually, let's look at it now. I'm not going to run that cell again because it'll append it twice. So if I run it here, you now have Charlie at the bottom. It's been appended to the main list. So the outer list, I appended a brand new row to it. This next example is going to add a new column. So if I were to run this and then take a look at sales data, run that, I now have another column just with zeros as placeholder values that I can then change. So if I wanted to change that first 0 to April, how could I do that? So the questions here, I see we have some, you have to index it to put it in a different spot. Well, you couldn't index it, you could insert. So we can look at those methods here, and we have insert right here. We can insert data into a list. So we could try that. So let's go back and just run this again. And then let's do, actually, let me comment this out and run it again. And I'm going to insert. And there now I entered Charlie at the top. So you can use the insert to add, if you want to put new salespeople at the top of the list, you could use the insert method to do that. So back to my original question. So sales data, 0. Got the answer here. And that's -1. Like that. I can look at sales data here. Oh yeah, I totally, because I had redone it up here, it kind of messed it up. But let me go back and I think this will fix it. There we go. So I have March back, and now I have April as labeled, and then I can then, as the month finishes, I can then change that for each salesperson. You normally wouldn't do that, of course, with Python. You wouldn't do like Python coding like this to update stuff. You would have, programs do that. And then, you would have your stuff in a database. But this is just shows a really good illustration. Conversely, I wrote a little script earlier just to kind of show how, not only can I use a loop to access stuff in a list, I can use a loop to create a two-dimensional list. So in this example, I have a board, and it's just an empty list. And then I went ahead and designated letters, though more programmatically, you wouldn't want to hard code anything. But in this case, I'm hard coding some letters for now. So I have a list of letters that I want to reference. In this case, this is going to be like a chessboard, if you will. And then what I'm doing is I'm going to use some nested for loops, and I'm using that I method, IJ method that I showed up here before, where what I want to do first, for each time the outer loop runs, I want to append a new row. So I want to make my first element that's nested inside of the board. And then in this inner loop, I want to use range, 1 through 9 instead of, I don't want to start at 0, I want to start at 1. And I want to then append in that one row the letters. I'm going to use letters at the index of I, which is always going to be 0. And then I want to make J increment up. So J is going to be a number. So this is going to end up being a nested list with tuple coordinates of the board. And I can show you in Python Tutor, but I just want to go ahead and print it out for you so you can see. So now I have a list that contains another list, and it's going to go all the way up to 8. So this is one element of my outer list, and each element is a tuple, and it has A1, A2, A3, all the way up to A8, and then it goes to B, B1, B2, B3, B4, B5, all the way up. And so you end up with 64 different coordinates to illustrate a game board, if you will. I can go ahead and put this in Python Tutor so you can see it there. Edit this code. All right, let's visualize this. Okay, so it's 156 steps, a little longer than the other one. But I have my board, I have my letters, and one is an empty list and one is a list, and I'm gonna start looping. So we're gonna start with I being 0, because I'm going from range 0, 8. Starting at 0, I'm appending an empty list into the board. And then J is going to start at 1. So using this range method, I have some optional. Instead of starting at 0, I want to start at 1. So this is my start, and then this is my stop. I want to stop up to, but not including 9, so up to 8. And then I want to start looping. So then my inner list, I want to append a tuple, and that's the board at the index of I, which is 0. I want to append letters at the index of I, which is letters, the index of I is A, and then J, which is a 1. So A1. And then it's going to loop again. A2. It's going to keep appending to that nested list. And you can see how this program gets pretty confusing, because it's starting to give me lots of data types and different, and it's really trying to show it to me in a very clear way. It just goes beyond my screen, so I have to keep like scrolling then. But this is how it's going to keep running. So it's going to keep adding tuples to each list, each nested list. So Athena's asking, I don't understand how the numbers are populated. You talking about the numbers in those tuples?
Yes.
Okay. So remember, J starts at 1, right? So inside this inner loop is going to run 8 times before it goes back to the outer loop. And so if you remember, J equals 1. So remember that, I just know that J equals 1. I can always reference that J when I want to, right? And so the first time I implement it's right here, I want to say, hey, the board at the index of I. So the board is what? The board is the list that now has a nested list in it. And I want to append a tuple. And the first index of that tuple, I want to put letters at the index of I. I is still 0. So letters is a list. Letters, the index of I is A. So the first element of that tuple is going to be A, and then just J. Well, J is equal to 1. So that's where J1 comes from. The next iteration, J is now 2, right? And I'm gonna do another append, A2. I is not incrementing. I is still at 0 because I'm only in the first iteration of this outer loop. I'm just going through this inner loop 8 times before the next one, before it ticks up 1 value. So does that make sense? It can be a bit much, but I just want to make sure that it's very it's a different way of thinking, but it is very, you know, procedural, and it has distinct steps. And once you just realize that when you have a nested loop, the inner loop has to finish completely before you increment the outer loop once. And if you have loops inside of loops inside of loops, you can then get a very, very long runtime. You can put a lot of pressure on your memory and your computer if you're doing a lot of stuff with nested loops. For loops like these, though, this is nothing for it to handle. It's pretty easy for a computer to handle. I mean, this, you know, on my computer here, I can run like a 5 million, like a loop with 5 million iterations, and it only takes like maybe 10 seconds, 15 seconds. So it doesn't take very long. But you know, you're logarithmically adding complexity when you start nesting your loops. And so it can make your run times pretty high. And we have a whole lesson for that too as well. So but does this pretty clear how it shows the nesting, and you're creating a whole board with this right here with this loop. It's just starting with A1, then A2, A3, A4. Goes up. Once you get to 8, your outer loop then increments 1. You start with B's, and then you do this inner loop again, and you're going to create all these tuples up to C, and then D, all the way up 64 items.
Yes, I believe so. And for the ranges, it's the first part for, so like if it says 1 to 9, it starts at 1 but does not include 9. And the same thing would be for the range above it. It would be starting at 0, including 0, and then not including 8.
Right, and you can actually have it that this would give you the same result. So you don't have to include a 0 because it will default to 0 if you don't include it. You have to include a stop though. So the stop is the only mandatory item for a range. So there's 3 of them. There's start, stop, and step. But if you only have one number, it'll always be the stop. And so that's why I would, when you're referencing like an incoming list and you don't know how long it is, you would just say the length of whatever the incoming list is to get your range, if you're going to use this way to loop. So
And the range means how many times it's iterating over.
yeah, so the range method itself creates like an iterable in memory that you don't see or think about. I'm gonna pull it up for you so you can see. And let me see if I have a. This is from the official Python documentation. So range. So range is an immutable sequence type. So it creates a sequence that you would iterate over behind the scenes. It's, you know, let me see if I. Yeah, so here we can list range. So we can cast range 10 to a list, and that's what we would get. Same with range 1 to 11, it's 1 to 10 because it's up to but not including. And then the range 0, the start being 0, the stop being 30, and the step being 5, it's going to give me every 5. So it will not include 30 because it's up to but not including 30. So I would stop at 25.
Thank you.
You're welcome. And so, you know, Tim, I started it at 1, just so whenever I get my results, I don't want to have A0. I wanted A1 because we normally count at 1, just to make it to where I wouldn't start with A0 or B0. It just the start being 1 up, you know, I only wanted to go up 8. Yep, I wanted to put a 9 there to go up to and not including 9. Let's go ahead and take a 10-minute break. So we'll just come back at 7:15 because we're almost done with this lesson. They only have a little bit left to go. And then we can go over some examples for the rest of the time. And then any exercises we've done prior. So let's stop here and do a 10-minute break. All right, welcome back. We only have a little bit to go in this lesson. Before we went on break, we looked at some examples and how to mess with two-dimensional lists. In one of the last examples, we were adding salespeople to a list of sales data, and we showed how you can add a new column of data, and also how to like maybe even insert a row versus just appending. So using those Python methods to manipulate the two-dimensional lists to get the result we want. We're going to go over a couple advanced techniques with two-dimensional lists. Yeah, I wouldn't necessarily say you're going to be using these tools for the the application, but they're still good to kind of think about. And this first one, transposing a two-dimensional list, kind of has some stuff in here that I did talk about it, some list comprehension before, but this one here I can explain. It's a lot. There's a lot going on in this one line of code. But you're going to see this quite a bit when you're out in the wild. You get through Code Platoon, you get your first job as a junior dev, and then you're going to see code in there that looks like this. And it's good to have the exposure to this right away, just because you're going to see it a lot. And so I wanted to kind of explain what's going on with this list comprehension because it takes a bit to understand. But in this case, I've already copied over to this Jupyter notebook, and we have a matrix here, and it has just two nested lists. We have a list of 1, 2, 3, and then another list of 4, 5, 6. So again, there's 2 items in this list, and each item is a list in itself, which has 3 elements. And when we transpose a list, what we're doing is we're swapping the rows and the columns. And so if I were just to run this to see the result, this is what I get back. I get back a nested list with 3 items, and it has 1 and 4 as 1 item, and then 2 and 5, and then 3 and 6. And what's happening is in this list comprehension, we are saying we're going to grab row at the first index for row in matrix. So I'm going to grab this one and this one for each row. So I'm going to grab row at the index, and you can start at 0. And then for I, which is still 0, in range of the length of matrix of the first element. So I'm saying basically, and it's really hard to explain, but what I'm saying here is on this side, I want to grab, I'm going to go the range of the length of this one row, because when you're transposing, you're going to have rows of equal length. So I'm going to grab the first row as an example, and I want to go through the length of that row, and I want to grab the first index of every row, and then create a new row with those. And I'm going to do that. I'm going to do that for each column of that. I'm going to get that result. If I want to write this traditionally, this is how I'm going to have to write it. And so Here, this gives me the exact same result. So in this case, I'm just using matrix, so I didn't redefine it up here, but all I did was I created an empty list called transpose 2, and I made a nested loop. And you've seen this before. So I'm starting at index 0, and I'm saying for the range of len matrix 0. So I'm still doing the same thing I'm doing here. I'm just saying, hey, for each item in this first element, I want to append a new row. So the first time this runs, I is going to be 0. And I'm going to create a new row in transpose 2. So a new list, a new empty list. So transpose 2 will have an empty list in there. And then I'm going to start my nested loop. And I'm going to say, hey, for J, which is going to start at 0, I just want the length of the entire matrix. So I'm gonna get the length of this matrix, which is only 2 items. And I'm gonna say transpose 2, and that inside that nested list I just created, I want to append matrix J, which is 0, and then matrix 0, 0. I want to append that. And then the next time it iterates, it'll be 1, 0. So I'm grabbing the first element of each nested list. And so the list comprehension doesn't show well on Python Tutor, but I can go ahead and put it in here so you can see this running. So you can see how I'm transposing the list. So I need to copy this over. So we're going to show the traditional loops first, then I will still show the list comprehension. And then I need to copy all of this over below. So I'm getting my data first. So I have matrix now is a list of lists. So it has 2 elements in the outer list, and each inner list is 3 elements. I'm going to make another empty list called transpose 2 because I want that to be my result. And then I is 0 initially, and I'm going to the length of this. This is matrix at the index of 0. That's what this first list. So I want to look at the length of this list, and I want to iterate over that in the outer loop. So I'm going to start with 0. I'm going to go ahead and append an empty list inside of transpose 2. So I do that. There's another empty list here. And then I'm gonna then go into inner loop, and that's J. J is also equal to 0 initially because I want to just go over the length of the entire matrix. So that's a list. Matrix is a list of 2 items. The outer list here of matrix is just 2 items. It's that first list and then the second list. And then I want to then append into transpose 2, which now has an inner list in there. At the index of I want to append matrix J and I. So I'm going to go ahead and do that. And then I wanted when next time this iterates, I'm going to grab the first index of the second element of that list and grab it there. And then I'm going to go up. I is going to equal 1. I'm going to append a new entry, and then I'm going to grab the second element of each nested list. So that's 2 and 5. So J is just going to keep cycling up and then resetting, and then we're done. So it's just going through and grabbing the first element, and then it goes and grabs the second element of each one, and then the third element. Any questions on that? I know it can be a bit confusing, and I know it can be a bit daunting. You don't have to totally get it now, but let me go ahead and show this other one as well. Let's see what that one looks like. And so this one, again, this list comprehension is not going to be as clear as the nested loops, but it really is doing the exact same thing. And so that's why I said, when looking at this, when trying to put this in Python 2, you really won't be able to see, it won't accurately illustrate what's going on very clearly. So this is good for like traditional loops. It can really help you with the step-by-step. That's why I broke it down into a different way of visualizing it, so you can see what's happening. List comprehension is easier for the computer to run, but for a human to read it and see what's going on, this is exactly how it would happen. So that is the list comprehension and transposing a matrix or a nested list or a two-dimensional list. Any questions on that material? We are about done. I was just going to show this last section on creating copies. If you remember, I talked about deep copy and shallow copies before. And I wanted to kind of illustrate this example here. So in this example, I have, I'm importing the copy module. So just like I showed you with Python, the modules, copy is one of them. And here I have an original list, and it is a nested list. So it's a two-dimensional list. The outer list has two elements. The first element is this list, and the second element is this list. Then inside of this one, I have two elements of 1 and 2. And what I'm doing is I'm making a copy from the original. So shallow copy is a copy. So I'm just using the copy method of the copy module. And I'm just taking a copy of the original and making it equal to a new variable called shallow copy. And then I'm running deep copy. And this one here creates a completely new object in memory. And what I want to illustrate here is I'm going to run this, and now I have those three variables. I have the original, the shallow copy, and the deep copy. And in this cell, I'm going to go ahead and change one of my values from, if I'm taking a look at my original at the index of 0 and then 1, so 0 is this one, and then 1 is the 2. I'm going to change the 2 to a string with 56 in it. So it's going to be 56 as a string. And I'm going to run that. And now I've only changed original, but if I take a look at shallow copy now, shallow copy actually changed. So I never touched shallow copy. I only touched the original. But if I look at the deep copy, that one is unchanged. So whenever you use the copy module, or if you create a new list that's equal to a list that's already existent, you're not necessarily making a brand new object in memory. You may be just creating an object that, a list that points to another list. And that's exactly what the shallow copy does. So you may run into that when you're like solving problems and you're creating lists, and then you're like, well, I need to make a copy of this so I can then reference my old stuff that I have. And you'll change the original, and you're actually changing the copy as well. You won't realize it. So I just wanted to kind of illustrate that point with these shallow and deep copies. It's the way that Python, when you're defining variables based on another variable, like another list, if you're creating a new list based on that one, if you change the original, you may be inadvertently changing the new one you just created. And that's exactly what I illustrated here. I never touched shallow copy, but it still changed when I changed the original. Because it's pointing to that memory location of the data in that list. It's not necessarily a brand new memory location. The deep copy is not immutable, so I can still change stuff in deep copy, because deep copy is just a name for a variable. It doesn't have to be deep copy. It can be whatever I want, right? So this can be like, new list, and this is like really new list. Okay, and I can do that. It's just I made them, the variable names were just shallow copy and copy. So here can be really new list, and this will behave exactly the same. So if I were to run this and then run that, this is the really new list, the one that's really, really new and will not change. So and it's not immutable. I can still change stuff in really new list. Really new list 0, 0 equals, and then so if I ran this and then ran that, I can still change it. It's not immutable. It's just a completely new copy. So, and it's a deep copy, so it's a different memory location. Any questions on that? Or any other questions? So these two-dimensional lists, data tables are huge. Understanding the concepts of organizing your data this way, when you think about spreadsheets, and databases, you're going to be referencing, nested lists. Rows and columns are kind of the big thing when it comes to nested lists. Is exactly what you're doing. You're organizing your data. Images. So the pixels in each image have, nested lists of, coordinates of where each pixel is. And so when you're thinking of like a computer screen, these 4K screens, have millions of these little coordinates that you have to go over. It can take quite a bit of computing power if you're doing image evaluation or machine learning. There's Python libraries for those that handle those bigger, arrays. And that's, they're designed for that. So you wouldn't be doing anything like trying to reference, the 1,000th element and then the sub element. You're not doing that stuff when you're working with images. Games, game board, like a chessboard, like I created above. That's where these apply. And there's all sorts of other examples of nested data values. I even go into other data values. So like a list of dictionaries, that one where you're changing the score, like of someone, which is right up here. These could be key value pairs. So Alice could be the key and the value 50. And then you would just be referencing scoreboard at the key of Alice. You can do plus equals 10. It's the same thing, In this case, we just have a nested list just to show us, how you could change the data. So there's all sorts of applications, and just thinking about how you can put that data into a nested list, nested data types. It's a fundamental skill to have, and it's good to introduce at this level. So that's it. That's for the end of lesson 7. So if there's are there any other lingering questions on the material we covered today, or maybe something you'd like to see again?
Hey, Aaron, I do have a question about the transposing. I guess I'm just having a difficult time wrapping my mind around I guess the necessity for having those two empty lists for I and J in order to then transpose.
So let me find where I have I think it's further down here. Here it is. So I don't have any empty lists. So I make one empty list in my second when I break it out into a nested like for loops.
Yeah, right there. That's what I meant. For the way that you did it for the for loops, I guess I'm just trying to wrap my mind around the reasoning behind creating those empty lists and how exactly that works. I mean, you showed it to me, but I'm still having a hard time understanding.
Okay, yeah, sure. Let me answer this question real quick from Daniel. So Daniel, there are no problems at the end of this one. So there are no exercises at the end of this, the rest of the lessons, because we want to give you time to focus on your application. So, yeah, so you have that, and then in examples I show you, and then what else, wherever, if you still want to practice on other stuff that may be a little simpler, of course you can go to Code Wars or any other those sites, register for a free account, and you can access those exercises. But going back to this transpose, so I mean, if we're looking at procedurally, right? So I want to end up with this result. This is the result I want, which is a transpose list. I started off with this matrix where I have 1, 2, 3, and then 4, 5, 6. I want to now make my columns the first entry of every row, and then I want to go down from there. So now 2 will fall under 1, and then 3 will fall under 2. And so all I'm doing is I'm changing it from this format to 1, 4, and then the next row is 2, 5, and the next row is 3, 6. There's application to that in like with data science. One of the examples is like Parquet files, which will, when you have normally like something that's column based, it turns the data into row based, and it's used for like big data processing. There's properties to having a transposed data structure to where you can speed up calculations. So when I'm talking big data, I'm talking like big cloud-based data lakes, like all the data in Facebook, for example. Like you have this stuff in data lakes. They have several data lakes, of course, but when you're looking at like all the information people post on Facebook, like you have to handle all that. I mean, everything you do on Facebook is put into a database somewhere, into a data lake, and then that data is cleaned and it's processed and it's kept. And so it's even hard to explain here, but it's big data. And so this is just a little bit of data, but we're showing how we can change its form with certain functions. So in this case here, what I'm doing is I'm building the transpose list with a for loop instead of with list comprehension. And so in this case, I have to go through it step by step. And so what I did initially was, I want to take a look at to come up with how many elements of my outer list. I need to take a look at the length of the first item in this list. So right now, the outer list of matrix has 2 items. It has 2 lists. It has 1, 2, 3. That's the first item. and the second one is 4, 5, 6. Well, to know what my end result is going to be, I need to take a look at how many items are in one element, because I'm going to flip this sideways. Basically, I'm going to have 1 and 4, and then 2 and 5, and then the third element's going to be 3 and 6. So I need to see how long this one is to see how many rows I'm going to have in my final result. So that's my first loop. And then I'm going to go ahead and create my first row, which is right here. So I'm creating my first row inside of my result by putting an empty list inside of transpose 2. That's all I'm doing. So, and then I'm going to now put the data inside of that nested list with this secondary loop. And what I'm doing is I'm taking a look at, well, now I need to grab, I want to start and grab the first element of every row inside of matrix. So I need to iterate over the length of matrix itself, not inside the element. So I want to just take a look. I want to grab the first element of every single item. You know, this could be a lot longer, but this one's just 2, right? So when I start this loop, I'm going to start at 0. And I'm saying, okay, well, transposed 2 at the index of 0, which is going to be the only item in there because I just created it right here. So I do have, you know, as this loop's running, I do have another list inside of here. You just can't see it because it's all happening behind the scenes. I want to append matrix J, which is 0, 0. So I want to append in the first one, I want to append the 1, so which is J is 0 and I is 0. So I want to append matrix 0, 0 to my first item in my new nested list. That's the first iteration. Then J is going to run again because it has to run on this row. And J is now going to be 1. And I want to grab the item at 1, 0. Well, matrix 1, 0 is the 4. So inside this nested loop, now I've appended 2 items to this list, and that's the 1 and the 4. This loop's done. I'm going to go to a 1. And then the 1 is going to be this next column. So I'm going to append a new row. So after this iterates to a 1, I'm going to append a new row inside of transpose 2. And then I'm going to go in here. J is going to be 0 again. And transposed at the index of 1, because now I is 1, J is 0. I want to append matrix 0, 1. Well, 0, 1 is the 2. I'm going to pin that on the new row. And then the next iteration, it's going to be the 5. Because matrix, this will be, J will be a 1. So that's a 1 and then 1. So 1, 1 is the 5. And then it's going to keep doing that. So that's kind of how this is going to iterate.
That makes a lot more sense now.
Yeah, it's really hard to wrap your mind around because of how these loops are running. But, you know, if you can just kind of think about, you know, okay, this loop's going to run and I'm going over the length of matrix 0. Matrix 0 is this. So I'm going over the length of this item first with my first loop. Okay. And then all I'm doing is making a new row in my new list. Okay. And now inside of here, what am I putting inside that nested loop? Oh, I'm putting the first element of each row. And then the next time it runs, it's the second element of each row. And then the third time. So that's really what you're doing. The list comprehension is doing the same exact thing, just in a more concise code fashion. And it's saying for, you know, I want to grab the element at I, so it's going to start at 0 for every row in matrix. So I'm going to grab the 1, 4, whatever else, if this is longer. And then I want to do it for every time I iterate over the length of this one. So I'm going to grab boom, 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 boom for I being 0. And then I'm going to grab 1, which is boom, 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 boom. And then the third one That's kind of how this is written. It's written a different way. It's more concise, and it processes differently, as you saw in the step by step on Python Tutor. It showed you how it gave you like a weird iter like object, and it really wasn't very clear what it was doing, but it's doing the exact same thing. Look at the results, same exact thing. And if I were to give it even more data, so I can just and I can space this out here. There we go. So now I've flipped it and I have 1, 4, 7, 10, 2, 5, 8, 11, 3, 6, 9, 12.
Okay. Okay. That makes sense.
Yep. Cool. I'm
Awesome.
gonna go.
Thank you, Aaron.
Yeah. I'm gonna go ahead and stop the recording here, but this room is gonna be open for another hour 15. So let me